Have you ever wondered how your favorite AI assistant predicts your next word or how Google Maps calculates the fastest route to your destination? Well, behind all this magic lies one of the most powerful tools in mathematics: differentiation. Stick around, and by the end of this video, you will not only understand what differentiation is, but also how it powers the AI revolution. And oh, don't worry, this won't feel like your high school math class. Imagine this: you are in a car on a highway and you are curious about how fast you are going right now. Not your average speed, like over 100 km per hour, but your exact speed at this moment. Differentiation helps us figure that out. Differentiation is like zooming into a curve on a graph to find the slope at a single point. Sounds cool, right? Well, it's not just cool, it's critical. From calculating speed in physics to optimizing machine learning algorithms, differentiation is everywhere. And trust me, once you get this, you will see math as less of a villain and more like a genius sidekick. Let's dive in. What is differentiation? At its core, differentiation is the process of finding the rate of change. It tells us how one quantity changes with respect to another. For example, in calculus, if we have a function describing your car's position over time, differentiation tells us the car's speed at any given second. Technically speaking, differentiation finds the slope of a curve at any specific point. Let me explain this. At first, I will draw two figures here. This is figure 1 and this is figure 2. This is point A and this is point B. This is slope, base, and this is height. I will draw a curve in figure 2 and take a point C on this curve. This is height and base of figure 2. For figure 1, height is half of the base, so slope would be 1 by 2. For figure 2, the straight line between A and B has a slope of 1 by 2, but the steepness of the curve is changing between A and B. So what would you do if you want exact slope at point C? If we zoom far enough, that is infinitely far, the little curve at point C would look like a straight line. Then you can find the slope in old-fashioned way. Wait, before you start imagining yourself rolling down that slope, let me ask, have you ever tried explaining calculus to your friends and they'd respond with, "Cool story, bro"? Stick around. I promise we will make this fun. Let's take an example you can relate to. AI in weather apps. Ever wondered how your phone predicts tomorrow's temperature or even the exact rainfall at 5 pm? Differentiation. By analyzing how weather patterns change over time, AI models use differentiation to calculate trends and make predictions. Another example: social media algorithms. Every time your feed changes based on how quickly you scroll, the app calculates the rate of change of your interactions thanks to differentiation. Talk about math being sneaky, right? Here's a quick visual. Imagine a curve that represents your car's journey on a graph. Differentiation slices that curve into tiny pieces to give us the slope of the curve at every point. Let me explain with couple of figures. I will draw here a graph, or at least try to draw. Y-axis denotes miles, while x-axis denotes hours. Some dots in x-axis and few numbers which represent hours. 1, 2, 3, 4, 5, 6, 7 and so on. And some dots in y-axis also which represent hours. 100, 200, 300, 400 and so on. Now I will copy paste this whole thing. A straight incline in figure 1. The straight incline starts at point A and ends at point B. A curve here. Also a curve in figure 2. A straight incline which touches the curve at point C. Now I will write here figure 1 and this is figure 2. For figure 1, if you know the xy coordinates of point A and B, you could easily calculate the slope. Slope equal to height by base equal to y2 minus y1 by x2 minus x1. This slope will give you average rate in miles per hour. For figure 2, by using calculus, you could calculate exact slope at point C. The slope for the single infinitesimal point on the curve gives you instantaneous rate in miles per hour at point C. But here's the big question. How does this seemingly simple idea transform into the brain of artificial intelligence? Hold on to that thought, we will uncover it in upcoming videos. Why we need differentiation? So whether you are solving a physics problem, optimizing AI algorithms, or just trying to understand how your phone is smarter than you sometimes, differentiation is your ultimate toolkit. It's not just math, it's a superpower for understanding the world around you. Ready to level up your knowledge? Don't forget to hit subscribe and turn on notifications because we are just scratching the surface of calculus and its role in artificial intelligence. Up next, integration, the partner in crime of differentiation. Until then, keep exploring, keep learning, and remember, the future of AI starts with you.